what you're seeing. So you should be seeing me about now.
You're there.
And I'll just do some magic here and then, okay. So that you should be good to see me with the slides.
You disappeared, Colin.
What's that?
You just disappeared.
You were there with the slides, but you disappeared.
Let me go again. I know what's happened there. Hang on one moment.
Yeah, you've appeared.
Yeah, it's the, there we go. It's the background filter has messed me up there. Great. So thanks for the introduction. Yeah, look, we've kind of all been speaking quite a bit about structural health monitoring, and we do a lot. And I kind of, you know, I'm really concerned that we do get the value of SHM out there and that it is increasingly used because, you know, as we've seen the introduction slides from Dusan, I mean, there are structures failing around the world. There are people losing their lives. And we have the solution to hand, and it's really it's very confusing to me in a sense as to why we are not keeping people safe with smart solutions. And I kind of come around and then question, what is it as a community that we're not doing so well in terms of selling the benefits of SHM to our clients? And so I think that's what you know, we need to try and work on a little bit. So I've kind of posed the question here for us: what is the value of structural health monitoring? And you know, let's think about why would we do it? Well, if we have perfect knowledge, we wouldn't need to do it, right? Structural health monitoring, in essence, is dealing with uncertainty, and so we must admit statistics into this. We do it because we're trying to reduce risk. We want to manage it and keep it to an acceptable level. We do it because, of course, cost is a thing. It's we have scarce resources and we must try and keep our costs to a minimum where possible. And of course, these three things combine in the space of making good decisions, because a good decision, you know, keeps people safe and isn't too expensive. And it's interesting that, you know, cost and risk are things that have not come up a lot yet in the last couple of days. So it's kind of, it's something that I think it's interesting. So like when we begin to think about what structural health monitoring can do for us, I always go back to this quote from Kofi Annan, which was made in relation to climate change, but it applies. Building a culture of prevention is not easy. Well, the cost of prevention is to be paid in the present. Its benefits lie in a distant future. Moreover, the benefits are not tangible. They are the disasters that did not happen. So how do we quantify something that doesn't happen? How do we derive value from structural health monitoring, which helps us to avoid calamity? And so there, you know, we've seen some talk about, well, structural health monitoring is just the right thing to do. And it is, of course it is. We all know it is. The problem is that that doesn't show up so well on a balance sheet. The right thing to do doesn't have a dollar. So sometimes people will suggest that structural health monitoring is a kind of insurance. Well, it is in a sense. The problem is that it doesn't pay out, right? So insurance, you pay your premium for an event that has a probability of occurrence, and as long as your premium is you know, lower than the probability of the event times the magnitude, the financial magnitude of the event, well, then it's insurance is value for money. But insurance doesn't, you know, structural health monitoring doesn't pay, you know, $500 million in reputational damage if something does go wrong. So I don't think it is an insurance policy. And so for me, our challenge is to try to capture its value in a financial sense that can be entered into a benefit cost analysis. And if we don't do that, I don't think we're going to get traction. So you know, this is a plot like of some of those issues we face where we have some true situation that, you know, usually we're looking at capacity or, you know, maybe crack width, serviceability, something like this. We have a true situation. We have some predictions. We go out, we take some measurements, and, you know, we're trying to push our model, which makes predictions, towards what reality might be. But of course, our measurements are uncertain. And our model itself is uncertain. So it's not straightforward, but of course we all here know that, right? We've also seen quite a range of structural health monitoring solutions. And so, you know, some may get us closer to the true value of a system. Some may push us away from it. Cost and accuracy are critical aspects of choosing a good structural health monitoring solution. So how do we choose one? How do we pick one over another? And so, to me, the value of structural health monitoring is rooted in the decisions that we make around the data it produces. So if we don't use the data, it has no value. So the first thing a client must be willing to do is to use the data, right? If they're not willing to use the data, they will derive no value. So we got to ask ourselves, and we got to ask our clients, the asset owners, what would you do without the data? And you know, what's the associated risk there? And then if you had the data, what kind of decisions might you make? And of course, with each of those possible decisions, there's an associated risk. And SHM's value is derived from the difference between those two situations, right? So you need to be willing to make different decisions on the basis of the data that's coming in. And that's where SHM gives value. If your decision is going to be the same regardless of the data, well, then there's no value to be gained. So that's a critical thing that, you know, I don't think a lot of people talk about. Maybe it's just me. Maybe I'm hanging out with the wrong people. So what does SHM informed decisions look like? And look, throwing in a little bit of maths here. Don't run away, please. So I think it's all really quite understandable. So when we make decisions in the absence of data, this is known as the prior, right? This is making decisions and before we see anything, prior, right? So we've got a bunch of decisions that are available to us. For some reason, they use the letter A quite a lot for this. We've got a set of decisions, capital A, and we've got, a single decision that we can make. And of course, these decisions influence the uncertain parameters in the system. We want to get the most benefit from the decision. So if I make a decision A, it's because it's going to give me the most benefit, and that will be the optimum decision, right? So I'm going to on average, I'm going to make the decision that gives me the maximum benefit, right? So that's our equation, the first equation there. And when I've made that maximum decision, the benefit I derive there is this capital letter B. So this is the prior. This is without any data. So when let's hypothesize that we've gone and spent a couple of $100,000 on a structural health monitoring system, and now I've got some data, right? So what happens now for me? Well, I use the data to update my information, right? And that's the model parameters theta. And then on the basis of that updated information, I make a new decision. And that new decision is A star, right? It's my different decision. And of course, that decision has a benefit attached to it. And that benefit, is necessarily a function of the data that I've seen. Makes sense, right? If I see data that makes me feel safe, I'll make a different decision, right? So that's why we have that functional relationship at the bottom. And so then it's called the conditional benefit. It's conditional on seeing the data and what the data is, because the benefit depends on what the data will be. And so this is the value of information that structural health monitoring provides, is the difference between these two situations. The optimum decision, the benefit derived from the optimum decision, having seen the data, subtracted with or subtracted from that is the is what I would have done, the utility I would have seen with no data. And of course, this should be a positive thing, right? Because we've responded in a more nuanced way with data. the problem, of course, is in trying to figure out whether or not we should use structural health monitoring. We don't already have the data, and this is the issue. So what can we do? Well, this is where it's a little bit subtle, but it's called pre-posterior analysis. It means making a decision before I've even seen the data, right? And all we can do here is try to take the average of the best decisions that we might make given all of the possible data that I might see. And so this is the average is just this this expectation thing here. So I'm just averaging over all of those those possible benefits that I would derive from this, right? So we'll zoom out there. So that's this is really the way to figure out the value of structural health monitoring. And maximize it, in terms of what are benefit or loss. Just of course, one is the negative of the other. So really, they're both captured in there. So that's the end of the maths, right? So let's have a look at what does this look like in practice. And our research has really been trying to pull the fairly esoteric stuff you've just seen into real world application. And in the real world application, we're kind of seeing. I'll just zoom in here a little bit. We have this kind of information where we have a capacity that we're trying to figure on. We've got some measurement that we might take, and we're trying to make a performance prediction. And usually, it's a probability of failure. And of course, given different probabilities of failures, we'd make different management decisions, on that basis, right? And depending on whether or not I have the structural health monitoring data, I've got the benefits I would derive with and without the data. And the difference between those situations is the benefit that structural health monitoring will give me. So in real engineering, we have tiers of kind of complexity in our analysis, in our assessments, and in our measurements. So these are the kind of different levels of complexity that we might consider. We might decide to use a line model for assessing a wide network of bridges. We might move to a grillage model for assessing a single bridge. We might then move to a three-dimensional FE model for getting in at a fatigue detail, for example. So we can apply these tiers across the domains of analysis, assessment, and measurement. So our approach, really works in real engineering sense, because those tiers then can feed into our capacity estimates, our performance predictions, and the measurements that we take as well. And finally, then we have what the decision trees associated with all of those potential situations. So before we see any information, we have our prior decision tree where we'd make certain decisions on the basis of what we think the situation might be. If we, think about a particular type of structural health monitoring system, type 1 here, we think maybe it's unbiased and it's quite accurate. What's the kind of decisions that we would make? And that's the pre-posterior analysis in the first instance. And maybe I'm thinking I could derive some really good benefit from some really cheap sensors that aren't so accurate, but it doesn't matter because I'm really ignorant right now. I don't know anything, so cheap system might really do well for me. So we can compare lots of different structural health monitoring systems and the potential decision trees that will enable us to arrive at an optimum decision. So a case study, example application of this, I need to emphasize this is not a real case study, but driven from a lot of my experience. So let's consider the idea that a bridge owner wants to allow an overload vehicle across a bridge. Straight up, should they strengthen or repair the structure? They don't really know. What kind of decisions are available to the bridge owner at this point? And then in that space, is structural health monitoring of some value? And if it is, what kind of structural health monitoring will be best. Cheap and accurate and quick to install, perhaps. Expensive, accurate, long-term. Which of these is the best situation? And I mean, to me, at the moment, these decisions seem to be made, on a fairly ad hoc basis. And I think we can formalize it a little bit better. So this is our bridge with our vehicle going over it. And, there's lots of things we could look at on these bridges. But one of the things that seems to be an issue is shear on crossheads. So we take this example crosshead of the bridge and we have a look at its shear, and we hypothesize what the decision tree might look like. So what I've got in this plot is where we start off in typical bridge engineering practice, where we look at a rating factor. And if the rating factor is greater than 1, we're on the top, we're on the do nothing space, where with the cost of a failure times the probability of failure is our risk. And the probability of failure here, where we've got a reliability index of about 5. So this is extremely low numbers, 10 to the -7, 10 to the -8 kind of space. But that's the risk. That number over here is the financial risk associated with doing nothing. But then let's move on down, right? Let's say, and this is more often the space I operate in, where the rating factor is less than 1, and the owner is considering a major repair. And here we've got a target level of safety, beta TY, so for yield. And if we're finding that the under this permit load, we think we're unsafe here, well, then we may go for the major repair situation. And so the decisions, what we're seeing here is the costs associated with each of the possible decisions. And you'll notice that at this point, we still haven't made any decisions as to whether or not SHM is in place, but at least now we have a quantified cost associated with whatever decisions we would make. And therefore, we can figure out the value that structural health monitoring can offer. And in the example, and applying the pre-posterior analysis and using 2 types of structural health monitoring systems, this is the kind of costs that we're seeing. So these are the prior costs and the pre-posterior costs. So we can see that depending on the shear strain that this permit load will induce, we derive certain amounts of value with and without structural health monitoring system. And so the benefit is the difference here between the red and the blue curves, right? And so if I plot the difference, we have something like this. This plot, I'll just take a moment because it's intuitive. What this plot is saying is that when the load is not going to stress the bridge that much, the decision won't change, right? So the value of the information derived from the structural health monitoring solution is quite low, and that's the left-hand space in this plot. And then equally, the right-hand space makes sense also, because you can think to yourself, well, this load is really overloading the bridge, and so there's no way that I don't need to do major repair. So putting a structural health monitoring solution on or system on, and it's not going to tell me something I don't already know, which is that I must repair this bridge. So the value of the information that we derive from the structural health monitoring system is low when we're in the very low risk space, and it's low when we're in the very high risk space. Where it has real value is right in that middle space where I'm a bit unsure as to what's going on. And that's when we see the most value from our structural health monitoring. And so that's kind of what I'm able to plot here. This plot's a little bit more involved, I guess. But what we've got on across the top is the shear strains. But shear strains on their own don't mean so much. So that's why along the bottom we've got the level of safety that these different shear strains imply. So this level of safety is a reliability index. You know, when we're in regions of low levels of safety, so we're over here in the plot, the decision will be major repair, right? This MR space. When we are in super high levels of safety, which is a lovely place to be, of course, the decision will be do nothing, right? Which is the DN. So the rating factor has passed. So the decision outcomes associated with the different possible outcomes and the values to be derived from structural health monitoring are all things that need to be brought together. So look, in summary, the things we kind of have learned from this kind of work is that the value of information is the means to assess the financial benefit of structural health monitoring. And I think without that, you know, it's going to be difficult to put this stuff on a BCA for clients. And one of the things we've also realized is that the reputational damage is tremendously significant. The aversion to any sort of risk must be priced in. And that reputational damage is a significant sum. It's not real money in a sense as simply a measure of client aversion to risk. We have to consider the uncertainties. Without considering uncertainties, there's no change in the decisions that could be made on the basis of structural health monitoring data. And as you've seen, the decision tree for a pretty realistic case study does require input from the owner in terms of their risk preferences and the costs that they associate with different outcomes, major repair, minor repair, load limiting, and so on. They need to really be a partner in a decision to apply SHM. We saw as well that the value that you derive from structural health monitoring depends quite a lot on the prior, because the prior is subtracted off the pre-posterior. And so you need to have, you know, reasonably good estimates and engineering expert knowledge in there first before you can derive the real benefit from structural health monitoring system. And as we've seen, it makes sense intuitively that the value you derive from structural health monitoring is very low when the decision is clear. If the decision is clearly the bridge is fine, there's no real benefit. If the decision is the bridge needs to be strengthened, again, there's no real benefit. It's in that middle area where you're not sure what the decision should be. That's when structural health monitoring really has a super impact, a large financial benefit. On the example that I showed, there was only 5 possible decisions, and what we found is the analysis really jumps between these decision points. So the more the larger the decision space available to the client, the better your SHM value can be to the client. So having that conversation with them and really nutting out all the different spectrum of intervention measures is really going to help you do a better job in deriving value from your structural health monitoring system. And the final thing, of course, is the whole analysis is quite sensitive to the cost inputs. And so having your client really have a think about what for example, reputational cost, what value they would put on that for themselves, and just making sure that your outputs, your answers are not too sensitive to those kind of uncertain inputs. That's an important point. So thank you for your attention, and I want to acknowledge my contributors to this work as well that you see there.
Great presentation, Colin. Thank you very much. I did think you cheated a little in that defining the value of information means that it's sort of a bit like, you know, what's the color of red? It's red. You've just called something else the same value and then attributed it. But I get your point is not that at all. It's that having the information to assess a structure allows you to make informed decisions. Am I interpreting that right?
Yeah, and you know, if your decisions are not going to change on the basis of the information that you've seen, there is no value to SHM. You know, the first conversation has to be, all right, if we go and put this SHM system out there for you, what kind of new and different decisions will you make on the basis of the data? And if they say there's no new decisions we're going to make, we just want some sort of certainty, there's not going to be a lot of value to be derived from that.
That's great. It's really refreshing.
I know you don't want to hear that, John, as a
not
supplier
at
of
all.
structural health monitoring systems. But if we can, at least let's all be honest about where we can really offer value.
I think that in my honest discussion with you here is that every time I get called about a structural health monitoring system, I, in the first instance, recommend not doing it. I think they've actually got very little value unless you've got a known problem. And certainly, I mean, we looked at that bridge down in Brisbane with a 300-year design life. It doesn't need a structural health monitoring system. The electronics are going to be destroyed well and truly before the concrete's got a problem, unless there's a sort of catastrophic failure that you couldn't have ever foreseen and you wouldn't be able to detect. And the concept that you can, I think, again, your work is very focused on shear capacity, which is a known vulnerability, and then you're assessing against that. I think there's concept of being able to detect failures. Bishan's work about 2 years ago, where a bolted joint with 20 bolts in it wasn't detected, or you could see change, but the natural frequencies went up, not down, for the first 15 bolts or first 5 bolts. And it wasn't until you got to about 25% of the joint capacity that you could actually detect it at all or identify there was a problem. And I think that those sorts of papers, I would have made a different conclusion, but I think they're really valuable. I think that that piece of work particularly, it really stuck with me. I made a different conclusion based on it, but I think that we've all, it's what I'd like to see more from this academic circuit. It would be work along those lines, reinterpreting that data and saying, actually, it's not a great idea to just look at natural frequency and infer damage.